So, for products of, we have monomials, binomials, trinomials, and in general, polynomials. So notice, monomials all means a single term, binomials means two terms, trinomial, three terms, and in general, multi-terms means polynomials. And this is sort of like FOIL, except it's general, so it's expanding. Okay, let's start with the 2x times in parentheses 4x squared. Do notice, we don't really need the parentheses as long as we have a multiplication sign somewhere involved. So you can convert this into a 2x times 4x squared. So as we multiply, we can multiply. Well, keep in mind, before we multiply, you're welcome to put a 1 wherever there is no exponent. So if there's no exponent, such as in that x, you can call it x to the first. So 2x to the first times 4x squared. Okay, so now let's multiply. So 2 times 4 gives us 8. And notice, as we multiply the same basis, in other words the x's, the exponents add. So we have a 1 plus 2. So we have 8 times x to the power of 1 plus 2. And let's combine them or add them. So that gives us 3. So we have 8x to the third. It's our final answer in this case. Once again, recap. Notice the coefficient is the number in front of the variable. Our base, in this case, the x is the base. It's the one that contains the exponent. And of course, the 3, notice that it's small and up high. It's called the exponent. So try to make your exponent small and higher, okay? So let's go for the next case scenario, our binomial multiplication. By the way, notice in the monomial we only got a single term, 8x to the third. So binomials then, binomial multiplication. So that means we're distributing to two terms. That's all that means, okay? So we're going to distribute then. Negative x times 3x or x times 3x. Keep in mind the negative, so negative x times 3x. And negative x times 5x to the third. So negative x times 5x to the third. You're welcome to parentheses. But remember, positive times the negative will give you a negative for that one, right? So it'll give you a negative x times 5x to the third. Keep in mind, you're welcome to put ones wherever there are just single variables. And you're also welcome to put a 1 before the x's. Agreed? So you have a negative and then a 1, x to the power of 1 times 3x to the power of 1 plus, in parentheses, negative 1 before the x raised to the power of 1 times 5x to the third. If you do not need the ones as a reference, you don't need to put them. But if you have a hard time seeing this, put a 1 in front of them or 1 up at the exponent. So let's continue on. Notice that 3 times negative 1 gives us negative 3, and x to the 1, we add 1 on both, right? So it's negative 3x to the 1 plus 1. Okay, for our second term then, it's 5 times 1 gives us 5, positive times a negative, still negative, so it's negative 5. And our exponents, we have an exponent of 1 and a 3. So to the power of 1 plus 3. So overall we have negative 3x to the 1 plus 1 minus 5x to the 1 plus 3. And let's simplify this. So in general we have negative 3x and then 1 plus 1 gives us 2, exponent of 2, minus 5x and then 1 plus 3 gives us 4. So exponent of 4. So our answer, negative 3x squared minus 5x to the power of 4. Okay, let's go for the next one. Trinomials, 3 terms. So we have 3x times in parentheses x to the third plus 4x squared plus 2x. So let's distribute this. 3x to the power of, or times, I should say, x to the third, or x to the power 3. Well, that's multiplication. 3x times x to the third. Going 3x times 4x squared. That gives us plus 3x times 4x squared. And 3x times 2x will give us 3x times 2x. Okay, let's simplify this. we have 3x, so 3 times 1 gives us 3. X times x to the third, keep in mind you can put a 1 if it helps, or otherwise it becomes a 3 plus 1 gives us 4. So 3x to the fourth. And then 3 times 4 gives us 12. And we have an exponent of 1 and an exponent of 2, so 2 plus 1 gives us 3. You're welcome to put a 1 again if it helps you visualize this. And then finally, 3 times 2 gives us 6. And then there's a 1 on each one of those x's. So 1 plus 1 gives us 2. So it's 6x to the power of 2. And once again, here's your final answer. 3x to the fourth plus 12x to the third plus 6x to the second, or we can call it 6x squared. So in general, polynomials. Let's try a couple at least. We have 3p squared times q, and then in parentheses 4p squared minus p times q plus 2 times q squared. So we're going to distribute to each one. Notice, in the parentheses, we can't simplify any of them. They don't have any like terms. Okay, so distributing 3p squared q times 4p to the second power, or 4p squared, will produce, well, we're just carrying the 4p squared over. So 3p squared q times 4p squared. Okay, let's go for the next one. 3p squared times q times negative pq. Once again, it's just a carryover of multiplication. Negative 3p squared q times pq. And finally, 3p squared q times positive 2q squared. So that gives us 3p squared q times 2q squared. Now let's combine some terms, or multiply as well. So 3 times 4 gives us 12. And notice, we have a p squared on both. P squared and the 3p squared and the 4p squared. So p squared gives us 2 plus 2, right? So 12p to the 2 plus 2, and we have a single q. Next terms, or next set of terms. Okay, we have negative 3p to the power of 2 plus 1 times q to the power of 1 plus 1, because there's one of each. Okay, and last, we have 3. Okay, 3 times 2 gives us 6. And in this case, we have a p squared, no other p's. And we have q to the power of 1 and q squared, so q to the 2 plus 1 then. Okay, so for the first term, we have 12 and p to the 2 plus 2. 2 plus 2 gives us 4. So 12p to the fourth times q. For the next term, we have negative 3, and then p to the 2 plus 1 gives us 3, so p to the third. And q to the 1 plus 1 gives us 2, so q squared. So negative 3p to the third q squared. And last, we have the 6, and then p squared, no combination with any others for the moment. And then q to the 1 plus 1, q to the 2 plus 1 gives us 3. So 6p squared times q. Do notice, none of these terms have any common terms. Since for the first term we have a p to the fourth, on the second term we have a p to the third, and last term we have a p squared. And likewise you can check the q's. We have a q with no exponent. Middle term has a q squared, and last term q to the third. So we won't be able to combine them. So continue simplifying polynomials, or in other words, distribution or expanding. Okay, so 3t squared plus 3t minus 4 in one parentheses. The other parentheses has 3t squared minus t plus 2. So let's distribute. Once again, we want to do careful distribution in this case, and I recommend showing arrows to make it easier for you to see it as well. So some careful distribution, or expanding. 3t squared times 3t squared will give us 3 times 3 is 9, and 2 plus 2 gives us 4. So 9t to the fourth. 3t squared times negative t, 3 times 1 gives us 3, negative, positive, negative. So negative 3, and then 2 plus 1 gives us 3. So negative 3t to the third. And once again, 3t squared times 2 now in this case. 3 times 2 gives us 6, and there's just a t squared in this case. Going for the next one, center term of the first set of parentheses times everything of the other parentheses. 3t times 3t squared will give us 9t to the third. Okay, Let's go for the next one. Keep in mind that there's a 2 plus 1 to give us the exponent of 3 for the other one, right? So 3 times negative 1t, or 3 times 1 is 3. Negative positive gives us a negative 3. And t times t, there's 2t, so t squared. So negative 3t squared. 3t times 2. Well, 3 times 2 is 6. And there's a single t, so it becomes 6t. And going for the last term, notice our green arrows. Negative 4 times everything on the other parentheses. Negative 4 times 3t squared. 4 times 3 is 12. Positive negative gives us a negative. And it's a negative 12t squared. There's only a single t squared. Negative 4 times negative t. Negative negative will give us a positive. So positive 4t in this case. Negative 4 times 2. 4 times 2 is 8. Negative times the positive will give us a negative. 4 times 2, once again 8, and it's a negative 8 in this case. Do remember, combine like terms whenever possible. So let's try to see if we can combine like terms. We have 9t to the 4th in this case. Well, that one has no like term. Keep in mind, the exponent is the only one that has an exponent of 4. So no other exponent is similar to that one. Okay, something I like to do is cross them off once I've rewrote them down below. That way I'm not tempted to combine them again with something else by accident. Okay, notice that we also have exponents of 3's. So we typically do it by highest exponent and go in decreasing order of exponents. So negative 3t to the third, we can combine it with positive 9t to the third. So negative 3 plus 9, or you can go the opposite, 9 minus 3, will give us 6t to the third. Notice our exponents don't change anymore, right? They only change when you're multiplying. With addition or subtraction, you keep them the same. And once again, let's cross them off. That way we're not tempted to use them again. If you don't have color markers or color pencils, you're walking through lines, different amount of lines. In this case, I put 1 line. And now we use 2 lines for the next sets. So we have a 6t squared minus 3t squared minus 12t squared. So let's combine them. 6, let's go. 12 minus 6 will give us negative 12 minus 3. Well, that gives us negative 9t squared. Keep in mind, there's more than one way you can add them, right? So I'll leave it up to you which order you choose to add those 3. Okay, but it gives us negative 9t squared. Notice the exponent once again does not change. Let's cross them off. That way we're not tempted to use them again by accident. Okay, all we have left now are the exponents, well, the variables that have no exponents, I should say. So 6t and 4t. So 6t plus 4t will give us, well, that's positive 10t. Let's cross them off. And finally, we are left with negative 8. So notice, we're practically done here. This is our answer. We have no like terms, so we won't be able to combine. One way to visualize this is if we think of fruits, similar fruits, right? We have 9 boxes of grapefruits. Let's say that represents the exponent of 4. We have 6 boxes of tangerines, exponent of 3. We're missing 9 boxes of melons and have 10 boxes of oranges. We're missing also 8 apples. Does that kind of give you a reference or a visual? Notice they all have different exponents. The ones that have variables all look similar, just like similar fruits, but you can still tell them apart, so we can't combine them. So once again, there's our final answer. And do realize that in the case where we got monomials, binomials, trinomials, and polynomials for our slide, we have the factored form. So these expressions are in factored form. On the other hand, what we got as our answer was the expanded form. You can go in reverse order and factor, but in this case we want to expand. It makes it, for this particular case, easier.